Okay, so we know how to solve a system of equations that are both linear, but what about when one of them or both of them are quadratic equations? Let's figure that out. So let's say this is the first system of equations I'm asked to find the solution for. And I want to remind you that finding solutions to a system of equations means finding all of the x, y pairs that are true for both this equation and that equation. And visually, that means the place where the two graphs intersect. So here I've got my x squared. This is a parabola. Here I've got my just x and y. This is a linear. And my y's, you can see, have just been brought over from this side of the equation. When I'm faced with it in this format, I'm going to choose to use the method of elimination, which means I'm going to doctor my top or bottom equation such that I have a variable that when I add the equations together, it will eliminate it. So I see I've got a negative y and a negative y. If I multiply my bottom equation by -1, I'll turn that negative y into a positive y. And when I add those two together, that will eliminate y from the equation. And if I have an equation in one variable, I can solve it. So I start by multiplying by -1, which changes this bottom equation to become negative x plus y plus 1. Now I add my two equations, x squared, and I have no other x squared, negative 3x plus another negative x, negative 4x, negative y plus y, 0. That was my goal. 2 plus 1. And now I have a single quadratic equation. I can solve that. I'm going to try the x method because this looks like it'll work. If x method is unfamiliar, go check out this video. Okay, a times c goes on top, b goes on the bottom. My factor list is easy. What multiplies to 3 adds to -4. Well, I can see that to add to a -4, both of those need to be negative. Those are my two factors, which means x minus 1 is 0 or x minus 3 is 0, which means x equals 1 or x equals 3. And now to find my ordered pairs, I'm going to go to the easier equation. I'll throw 1 in first. So -1 plus y plus 1 equals 0, y equals 0. So my first solution is the ordered pair 1, 0, and then I do it again. -3 plus y plus 1 equals 0. So y equals 2. And so my second ordered pair that works for both equations is 3, 2. I would throw those each into this quadratic to make sure that they worked for the quadratic as well, and they do. And so I know that when I graph these two and I graph my parabola and I graph my line, these will be the two places where the line intersects the parabola. Okay, let's take a look at a different setup of a parabola and a line. This time, they're set up so that each of them equal y. My method here will be substitution, because if this equals y and this equals y, I can substitute 4x minus 1 in for this y and set the two of them equal to each other. So there's my first step. 4x minus y equals 2x squared minus 3x plus 9. I'm going to pull everything to one side of the equation. When I subtract 4x from 3x, I get 7x. When I add 1, I get 10. This doesn't look like it's going to be fun to factor, so I'm going to jump straight to the quadratic formula. If you're not familiar with it, go check out this video. Otherwise, write the formula on your page to start. And I can't see that formula without thinking of this song. And if you've never heard the quadratic formula song, go watch this quick video. It'll be in your head all day long, but you'll never forget the quadratic formula. Meanwhile, let's put our numbers in here. So negative b, -7, plus or minus the square root of b squared minus 4ac all over 2a. Well, as I take a look in here, 4 times 2 times 10, 80, and 49 minus 80 Negative 31. Okay, this is imaginary. We don't have imaginary solutions to lines. Therefore, this line will never hit this parabola. So in your solving, if you encounter a negative under the square root, and that means you're encountering an imaginary number, and if that doesn't mean anything to you, go check out this video, then that means the answer to your question is there are no solutions. They do not intersect. Okay, now let's take a look at how we would solve if we have a parabola and another parabola. Okay, so I have a parabola that opens up. I have a parabola that opens down. They are both in the format of equals y. So I'm going to solve using the method of, that's right, substitution. I'm going to start by setting them equal to each other. And now I'm going to bring everything over to one side. So I add x squared to both sides. I subtract 2x from both sides. I subtract 3 from both sides. And once again, I'm looking at something kind of ugly. I'm going to jump straight to my quadratic formula. All right, here we go. Negative b, negative 5, plus or minus the square root of b squared, that's 25, minus 4ac, all over 2a. Okay, great. Minus 4 times 2 times minus 7 winds up being plus 56, and 25 plus 56 is 81, and aren't we lucky? So that's a whole number. And here we go. 5 plus 9, that's 14 over 4. That's 7 halves. Or 5 minus 9, that's negative 4 over 4. That's negative 1. So those are our two x's. Now we go ahead and throw those into either equation. And when you throw negative 1 into, let's say, this equation, so that's 1, and then we have minus 3 times minus 1, or plus 3, so that's 4, and then minus 4, that's 0. So negative 1, 0 is one of our answers. And then using our calculator, when we plug 7 halves into this equation, we get negative 2.25. And for consistency, I'm going to write that as 3.5. And so those are the two places where these parabolas will intersect each other. And you can run them through this to make sure that they work for both, and they do. Okay, take a look at my other videos on parabolas and quadratic equations. Check out my factoring playlist if you need help with factoring. Leave in the comments any problems that you're working on that you would love to see a video on. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.